Welcome to the course. This course is all about robotic arms and ROS as well. But first, we are going to dig deep into basic understanding of how robotic arms works because we have to first understand that, then we can build in ROS. That is mandatory. So let's take a look how robotic arms work. Basically, there are many manipulators, and what I mean by manipulator in robotics theory is you can manipulate any object, any physical object in 3D space by a machine, a robot, without even directly touching it. So using that machine you can manipulate its location, manipulates its mass through a manipulator. That's what it is. Most popular manipulators are robotic arms because as they are of hand shape, they are easy to manipulate things. If we connect this robotic arm on a mobile robot, it becomes a mobile manipulator. In manipulators further, there are two major types: serial or parallel. In this course, we are just going to be dealing with serial or chain manipulators. We are not going to be dealing with parallel manipulators. Now, this circular thing or this one, these are known as joints. These are the points where actuations happen, where motors are connected, where the robot is feeling motion. These bars which connect these joints with each other, J1 and J2, are connected with link 1. These are known as links. So in a manipulator, two major things are joints and links. Okay, that's the basic concept. At the end you can see a claw. We call it to be end effector, as it is written. Through end effector we can manipulate things. This serial manipulator, when converted with multiple serial manipulators in parallel, it becomes a parallel chain manipulator or parallel manipulator. There are multiple types of it, but we are going to be discussing only serial. Why we call it a chain manipulator? Because joints are connected with the help of links in a chain or serially. That's why it is known as this serial manipulator. Coming to the point of the basic working of these manipulator, there are two major things in its motion: the task space and the workspace. Here it is a 2 degrees of freedom manipulator, meaning only two joints are available inside of this manipulator. The dotted lines available on the screen in the first graph are basically representing the possible motion of these joints. These red dots are representing the possible motion where this end effector of our robotic arm can be in this scenario. For example, this is the current angle of θ1, joint number 1 angle, and we have drawn all of the possible values of our joint number 2 motion, which causes the motion of our end effector. So these are all the possible values when we have a constant θ1. Then these are the all possible values of θ1, not the end effector. So which is basically in some text is known as joint space, which means that all possible joints motion. Coming to the next graph, which is the second graph, which tells us all of the points that with the combination of all of the points of θ1 and θ2 the end effector can make. Okay, you can see there are huge number of points, or very with a lot of values that this end effector in xy, as it is 2 degree, only 2-dimensional place will be created. So end effector can reach with the help of just two joints, sort of curves over curves over curves. This whole area is known as workspace. Workspace is a place in which your robot can reach. Okay, all possible values where your robot's end effector can reach is known as workspace. Okay, this was the first thing that we need to discuss. Now coming to the next point, which is the task space. If we see on the third graph, Here we can see that there is a circle inside of our workspace, and the task specified for this problem was to draw a circular area inside of any 2D space. So obviously the robot can only draw things inside of its workspace, so that was our task space, and task space is always limited as compared to workspace, because task space is totally dependent on workspace. Task space depends upon the task, but it can only happen in your workspace. So this was the basic concept here for task space and workspace. Coming to the next point, which is very interesting and important, and it is known as kinematics. Kinematics in robotics is very important, and it is not related only to manipulators. Mobile robots and other robots as well inherit this concept. Two major types, or we should say two categories we defined kinematics, are forward and inverse. Forward is the easy one. For example, we are first dealing with forward kinematics. In forward kinematics, we basically tell the angle of Q1 to rotate is 0, angle of Q2 to rotate is 20 degree, rotate Q3 to 20 degree, and Q4 to 30 degree. And then when we know these angle values, we can tell what is the effect and what is the location of end effector. So we knew angles, all of the angles, we can then tell what is the location of our end effector in X and Y and theta as well, orientation. So basically we give the angles and we know where our end point or the tip of our hand is going to be in the XYZ. So this is forward kinematics. What we have to do, we have to provide the angles. But in real terms, what happens? We don't say that rotate your first joint to 20 degree, rotate your third joint to, let's say, 60 degree, and we might come to the point of reaching a cup that is going to be the future project of this course, or glasses or mobile phone. What we do in real term is we say reach that mobile phone, reach your glasses, make your robot move towards the cup. So this is what we do, and for that reason we use inverse kinematics. And inverse kinematics requires a forward kinematic solution. Without it, inverse kinematics is not that much efficient, or a very hard process is used if we don't use forward kinematics. So forward kinematics is going from base to the end effector. Inverse kinematics is utilizing the forward kinematics equation, and we just tell move your end effector to 2 in X, in 2 of X and 2 of Y, meaning where X is equal to 2 and Y is equal to 2. Adjust your angles by your algorithm and make your robot move to that position. This is the most important and interesting thing of this course, and that is inverse kinematics that we are going to be dealing with. So if we formulate it, we give the XY of the end effector we want, and it generates angles for all of the joints.